Physical changes. A physical change only affects the state or the appearance of the substance. It doesn't affect the composition. So what that means is the atoms or molecules, the Lego bricks that it's made up of, are going to stay the same. But you're maybe going to change how they're spaced apart from each other or something like that. So I don't remember what's on the next slide. So here's an example, water boiling. So if we look at the little water molecules, I don't know about you, but those look like little Mickey Mouse heads to me. Red and white Mickey Mouse heads, that's water. Okay, so here's water as a liquid, all touchingly close and real close together. And then when it boils, it moves apart from each other. And that's actually not to scale. There would be more space than that in between them. But the individual little Mickey Mouse heads are still little Mickey Mouse heads. All the particles are the same in a physical change. Another example of a physical change would be taking a piece of wood and cutting it in half. The particles are still wood. Now the big block of it is in two pieces, but the particles inside are still the same. So anytime you have a state change from gas to liquid, liquid to gas or whatever, it's going to be a physical change. The other kind of change is a chemical change in which the individual molecules or atoms do change. So a chemical change alters the composition of the matter. So here we look at this nail, and the nail is made of iron. The iron forms a crystalline structure. We have regular repeating pattern of iron atoms. When it rusts, now it is different. Oxygen atoms are incorporated into the structure of the iron, and it has changed. It's not the same anymore. The individual particles are not the same. There's a rearrangement of atoms. And so that transforms the original substance into a new substance. The iron of the nail isn't there anymore. It has turned into rust. The iron atoms are still there, but it's turned into rust. And rust doesn't have the same properties as iron, right? I have an old Mustang, and it's got some rust on it because it's from the Midwest. And, you know, the rusty parts, you can take your finger and just poke them, and they just flake away, right? The solid steel parts don't do that. Different properties. It's a different substance. So rusting of iron is a chemical change. We have a transformation into different substances. Not just that it's changed its shape or its appearance or anything, but it's actually a different substance. That's a chemical change. So here we have dry ice subliming. Dry ice goes directly from the solid to the gas state. Not many things do that, but carbon dioxide does. That's why it's called dry ice, because it doesn't melt and make a liquid. It just turns into carbon dioxide gas, which disappears and you don't even realize it. So as a solid, we've got these little black and red carbon dioxide molecules. And in the gas state, we still have the carbon dioxide molecules. That's a physical change. It's not a chemical change. Here we have sugar dissolving. So there's the chemical formula for sugar. Here it is a solid, and here it's aqueous. We're taking the sugar here that forms a nice crystalline structure. We put it into the water and look at the particles. Are these particles the same? It's not a trick. Do they look the same? Yeah, they look the same. It is the same. The particles are separating in the water so that they can mix throughout and make a homogeneous solution, but the sugar molecules are not changing. If you took sugar water and evaporated all the water, what would be left in the container? Sugar. It's the same stuff that it was before. It's a physical change. There's a change because we mixed it, right? Here's an example of a chemical change, propane gas burning. So here's the propane, and that reacts with oxygen and forms these guys, carbon dioxide and water. Look at the particles. Are the particles changing? Yes. We don't have any of these propane particles anymore. The carbon and hydrogen atoms are still there, but they've combined in different ways now, and they've formed new substances. It's a chemical change. So this kind of summarizes, oh wait, no, this is slightly different. We've got chemical and physical changes, and then we've got chemical and physical properties. They're related, and yet they're not the same. Physical property is a property that a substance displays without changing its composition. So can you observe this property without actually causing the substance to change? You smell gasoline. Does that change what the gasoline is? No. If you look at the color of something, does that change what it is? No. If you measure the melting point, now measuring a melting point, you have to melt the substance, but when you change the state of something, it doesn't change what it is. It's a physical change. If you measure the density or the mass or the length, it doesn't change the particles. Chemical property, if you display the chemical property, you're going to have a chemical change. The substance that you started with is going to be destroyed, and you're going to end up with a new substance. So gasoline is flammable. Gasoline burns if you set a match to it, right? That property is a chemical property, because to demonstrate that property, you have to destroy the gasoline. If you're going to measure the volume of the gasoline, you can do that without destroying it. Volume is a physical property. Other examples are corrosiveness, acidity, toxicity. Excuse me. It doesn't choke me up. I just had this random catch in my throat. Those are all examples of chemical properties. So, what should you know from all of that? You should be able to look at something like this and determine whether these are primarily physical changes or chemical changes. Frost forming as the temperature drops on a humid winter night. Physical. Because what's happening there? You've got water, vapor, forming a solid. So that's physical change. A cornstalk grows from a seed that is water and fertilized. That's a chemical change. The cornstalk, did you ever wonder where all that volume and mass of the cornstalk comes from? It's not just the water, is it? And it's not just the stuff that comes up from the soil. It comes from the air. It comes from carbon dioxide in the air. The plant takes the carbon dioxide and makes cellulose out of it and makes this big, bulky, these trees, most of that comes from the air. I just realized that like a year and a half ago. I was like, wow, I just never thought of that before. So now I have to tell students because I just thought it was cool. Definitely a chemical change. A match ignites to form ash in a mixture of gases. Chemical. So one of the keys or the clues that you look for to form, anytime you see that, it's going to be chemical. Perspiration evaporates when you relax after jogging. Physical. There we have state change. Evaporates. A silver fork tarnishes slowly in air. Chemical. The silver is reacting with oxygen in the air and forming a tarnish. Any questions?